Today I'm going to cover with you one way you can measure an impact without tracking, and how I use it successfully in the past, and how you can use a code in Colab, which is great because all you need is a Google account to be able to rerun the code on your side and update your data set. I'm Charlie, I come from investment banking, and now I help enterprises to reduce their CAC, increase their margin, and scale profitably. So the tool I want to talk to you is the interrupted time series. So interrupted time series, as you can see, what we do is that we estimate what would have been the trend without the impact, and then we run the impact, and then we get the difference. That's basically what we do. So the way it shines is that it's great for cross-platform attribution. For example, if you have an e-com and you sell a lot on Amazon, for example, well, your marketing on Meta can drive a lot of transaction on Amazon. Obviously, on Amazon, you can ask things like, how did you hear about us? So that's a great way to find out the impact of Meta on your Amazon purchase. It's also very useful for untrackable events, like, for example, OH, PR, a lot of things that are offline that doesn't allow you to have tracking. Those kind of tools can help you to better understand what is the impact. So my experience is exclusively enterprise and high ticket. And that means that it's usually a longer consideration journey, and the percentage in market of your ideal customer is low. Like usually in B2B, we say 5%. And the reason why it's important is because those kind of models need a burst to be able to measure it. And this is a big caveat that I have with incrementality that everybody talks about, is that it needs that burst to be able to measure it. So it becomes much less reliable when you have a higher ticket and a smaller percentage of your ICP in market. And in that case, what you can do, you can use metrics that are happening earlier. And this is how I use it a lot successfully. So for example, for a company in the past, they wanted to understand what is the impact of LinkedIn posts. And what we did is that we found out with that kind of tool that it was drastically increasing the number of job posting views on their website when they were posting on LinkedIn, even if it was not trackable at all. We also implemented self-attribution there, and the two were saying the exact same thing. So we were quite happy with the results. And because we had two sources saying the same thing, we were quite convinced it was the right thing. Impact of programmatic ads on event subscription. So you might have heard about it. Big events like Oracle, Cloud World, Snowflakes do something similar. So all of those events are paid events, and about like $1,000 for a few days. So the person will never subscribe to that event just by seeing the ad. They will see the ad, they will be reminded, and then they will go ask for approval to expense that to the finance team, and then tell by to brand search or organic search. And so in this case, it was very difficult to prove the value of this digital display ads. And so what we did here is that we used that tool to be able to measure the impact. And we did that also for emails, and we succeeded to understand what was the best way to convince our audience to come to that event. Another successful test we run with that method is the impact of TikTok and other social organic views on website visits. So those channels are designed for you to stay on the app. And so the thing is, people are not just going to leave the app and go on your website. Also, it's on a small screen, so people are often more comfortable to look at something on a bigger screen, on a laptop, etc. So people will Google the website and then go on your website. They're not going to follow a link from TikTok to your website, especially when it's organic post and there's no link, because usually you have to click on the profile, and then you have to click on some kind of a tree where you have all the links, and then you go on the website. So people will just go on Google and search it. And so that way you could see the impact of organic search and also the impact of your boosting campaign. So your organic initiative that you boost, and you'll be able to measure an ROI on this. Another way I use it successfully is to use Holdout DMA when vendors' claims are exaggerated. So in this case, it's very important that the claim is very unusually big, because we will talk about the noise later. For the impact to be measured, like, we really need to have a signal that is much bigger than the noise. So in certain cases, when you have a vendor claiming, for example, 2-digit ROI, you can often question that claim with a simple tool like this. I'm going to go to the gotcha later. They're here, they're in the notebook, you can see them, but I want to go now in the example. So what we did here is that we created a fake data set of 60 days. We have our test start date on that date, which is about 30 days later. So we have 30 days pre, 30 days post. We create a data set with days. So with trend, we add a little upward trend line, we add seasonality, and then we add noise. This is very important because as you can see now, we have a very small scale, which is not a lot of noise. We're going to rerun this with more noise, and you'll see the impact. So this is how the data looks. We have dates, we have values, very classic. We have our start date, which is different than here. Test start. Okay. Well, anyway, it's working. I'll change that in the code to make it a bit nicer. But this is how it looks. So we have the data before, we have when we start test, and then we have the data after. Here in that case, we really see the very big change because there's not much noise. You see this weekly seasonality and so on. So and the things we're going to do is that we see that we have weekly seasonality, we have trend. So we're going to create our trend, we're going to create our day of week, and we will assign that into our model. And so here, as you can see, is we are using a Bayesian model. It's a PyMC model, linear regression. The reason why I like Bayesian model is that because you have confidence interval. And I'm going to cover this now. So all the way up in the notebook, you'll have the link that send you to this website, which is absolutely amazing. And this is an example of what a confidence, 94% confidence interval is that I'm going to show you. So what it says here is that there's 95% chance to be between 14.8 and 22.7. Now, as you can see on the distribution, well, it doesn't say, oh, there's a same change for your data to be 14.8 or 22.7. That is not true. It's like, this is like in 94% of the cases, this data will lie there. As you can see in the distribution is much, much higher on the mean. So there's a way more bigger probability for the real result to be on the mean than on the extreme. So this is sometimes like a bit of a misconception of what confidence interval is. So I just wanted to show you this. This is, by the way, a great website. I really suggest you to go through this. They go through many examples, and all the methods have their own example, like synthetic control. We have the effect of Brexit here. We have some effect on excess death during COVID. And all of those really help to see an impact without creating a geotest. And I'm going to talk about the geotest later in the caveat. So if we go back to our model, so we see we have our confidence level. So we have the intercept, we have the T, which is the trend. So interestingly, you see that trend is slightly higher than what we meant, probably because a bit of a noise, but we have the confidence level of any day, all the days of week. So what it says is that the performance tend to be lower during the weekend than at the beginning of the week, which is usually what happens, well, in B2B mainly. This is the model. So it's very clean. Like you have the pre like this. You see that the model is really very well following the weekly seasonality, and then boom, you have that burst. And so this is how they're going to define the causal impact. And the causal impact, what is great is that you do have a confidence level here. You see the noise. And so the noise will be detected to make sure that this is exactly what we believe is really causal. And then you have the cumulative causal here. So you can summarize it into, if you do this, you just summarize by day. So it says that the impact has an impact of 11 per day with a confidence interval between 10.4 and 11.5. So you can see the interval here is very, very narrow. Again, as I said, even if it could be 10.4, it's very much more likely that it's around 1097, going back to the distribution. And then you can do the sum on the cumulative, which is giving you a mean of 329. So what is good about this is that, for example, if you run a test and you spend in total $100 during 30 days, then you can divide that mean by your $100 and you can say, okay, well, the estimation of what we did here had an impact of 3.2 RI. Assuming, well, we're talking about revenue here. Revenue works with a cheaper item, smaller conversion window, a higher percentage of people in market. So this will really depend on the business, the way you define your metric. And here it's it's a very quick ACF plot to see if the residual look okay over time and to do so we don't have any autocorrelation problem. So it is as simple as that. Now, we will see, look at this. It's very clean. And now we're going to change the noise in the data. And now back to the initial idea, which was increasing the scale. So I'm going to increase the scale to 5. So we go from 0.5 to 5. And I'm going to run all. I could have saved a bit of time by not rerunning the lib, but I mean, it was just easier to just push a button. So we have a how does the data you see? So now it's way more noisier, you see, and even like we had our upward trend, but that upward trend is not even visible in the pre because of the additional noises we add, and it's so that's becoming an interesting case. So we're going to let the model run. As you see, it's running. There we go. And as you can see, is that here now, the data is not as clean at all. So it's going everywhere and the causal impact is going there. So what do we see? We have a mean of 16. So it's actually higher than it used to. It has a confidence level between 11.8 and 20. And the mean, interestingly, is much higher. So this is a bit of the problem, is that when you have noise, it can sometimes be a bit misleading. So that's one caveat of it, is obviously all of those correlation models, but incrementality, geolift, MMM, they will all struggle with that kind of issue. Okay, so now I'd like to come back to the cons of those kind of models. Is the gotchas. So the seasonality. Yeah. So seasonality, obviously, because we're just predicting what's going to happen after, and then what we predict what's going to happen over the next 30 days with the last 30 days. If there is a seasonal movement that's happening in the next 30 days, this change will be assigned to the treatment. So obviously this is not true. You can use year-on-year seasonality to control for that, but there is a lot of but. For example, a lot of seasonality model that we're using are Fourier transform. The problem with Fourier transform is that it doesn't work very well when events are not on the same date. Which is the case of Black Friday, which is the case of Easter. So be careful with those seasonality model because there are some caveats with them. Also, random noise and false positive. As you can see, when you add noise, those models can tend to behave a bit differently. So we saw here an interesting case where actually there was more allocated to the treatment. And so you have to be very careful that the impact is clean enough to be able to see. So the cleaner is your signal, the better will be the results. So obviously, as I explained here, you can use a geotest, but if you have a weather swing, for example, that is happening in one of your treatments, even in a geotest is not going to be able to manage that. You can have competitors promo. If a competitor's promo is happening at the same time, a geotest could be a solution unless the competitor promo is in specific geos. So it's very important that you really fully understand what's going on so you're really able to capture the signal. The thing also is that, as I explained, the signal dies off over time because you have that signal and then it goes down and then you have that noise, and then at some point that signal will be completely absorbed. And so you have to use metrics where the signal is strong enough. So obviously, as I explained, if you have a lower percentage of your customer profile in market at any given time, and if the consideration journey is longer, which is the case when you buy a car, which is the case when you book holidays, when you buy a dishwasher, when you buy a $500,000 B2B SaaS contract. So all of those are going to impact the result of those kind of models. And geotest is not going to help on that neither. So also it's an on-off, what we did here. And the problem with the on-off when we work with marketing spend, for example, is that we don't really have the concept of diminishing return. And so yes, here we said an example, the ROI could be 3.2, but where we're at in the diminishing return curve, we don't really know. And sometimes I had tests that was completely inconclusive, and then we found out that we were just overspending already. And so what I usually do then is that, well, I investigate, and when I think it's a diminishing return problem, then I would do like an opposite test where I would pull off spend and see if I can see a change on that way. And then usually, if you don't see an impact because of diminishing return and you pull the spend, you should see an impact going down. It's also short term. So that's one problem is, as I explained, is a short-term burst. If it's not going to model you the long-term impact, and there's no incrementality solution that is going to do it. So that's a caveat with those kind of tests. But the thing is, if you sell high-ticket products, you can still look at product request, product demo. You can see like number of visits to your website, number of visits in your shops. Those are the other indicators that are happening a bit earlier in the funnel that has a bigger burst that can give you a better insight on what is the impact. Now, obviously, you'll have that problem that you'll have to solve, which is how do you value, for example, a site visit into revenue? Knowing that when you push site visits, you don't know if all of those site visits are equally valuable. So maybe you can push a lot of site visits, but it's not your ICP. And so in the end, what's going to happen is that the real value by visit is going to go down during your burst because you're not bringing people who are actually buying. And so this is also a caveat that you need to understand when you use metrics earlier in the funnel. I hope you enjoyed this and see you next time. Bye.